So in this section, we'll be looking at circles, and we'll again be giving these same three representations: a visual, an equation form, and a set notation representation of a circle. Here, I have written the expression for the distance from x comma y to the origin. Remember that this is really just the Pythagorean theorem. This x minus 0 is the distance between x and 0. This y minus 0 is the distance between y and 0. And this expression just tells us the hypotenuse of the right triangle that naturally arises from looking at x, y, and 0, 0 in our coordinate system. And we're setting this equal to 4. Now, we could stop here and say that this is our solution for part 2 here. In other words, this is our equation representation of our circle. But we can clean it up a bit, which is nice to do for posterity. We'll appreciate that when we use this equation later if we write it in a form that's slightly easier to look at. In particular, this square root makes it kind of ugly to look at. We can square both sides in order to clean things up. We should wonder for a second whether squaring both sides is going to be problematic, whether this is going to possibly introduce false values of x and y that would make this true, or whether it would somehow eliminate values. So squaring does sometimes cause problems. In particular, suppose we have some variable a being equal to -3. If I square both sides of this equation, I now find that a squared equals 9. If you hand me this second equation and say, what's a? I look at it and say, oh, a is plus or minus 3. Could be either one. And I can't say that a is specifically -3. But the reality is that what we started with was a being equal to -3. So when I square this equation, what happens is that I possibly introduce a new invalid solution. In other words, if I look at this one and conclude that a equals 3, I'm actually making a false conclusion. Do I need to worry about that in this case? Well, let's write out what we get when we square both sides of the equation, and then consider whether there's possibly a problem. Are there any extraneous solutions? Are there any solutions to this manipulation of this that do not appear in, that should not be allowed? Well, no, there aren't. Then why is it that when I start from here and square it, I introduce an invalid solution, a possible value of a that is not what we started with? But if we start from this and square it, we get something that is apparently exactly the same as this, with no loss or disruption of information. This is actually quite a non-intuitive issue, and rather than resolving it here, I'm going to leave it open for discussion.